Hello scholars, welcome back to IOS YouTube channel. So today we'll be looking at Solow Growth Model. So in Solow Growth Model, we want to determine the capital per output. And when you are given these functions, for you to determine the capital per output, the first step you need to take is to divide the both sides by your labor. Then the labor is this, your L. You need to divide the both sides by the L, which stands for your labor. So here we'll be having Y equals to the capital raised to power alpha multiplied by the labor by, and this E stands for the efficiency of labor. Then I'm having Y minus the alpha. So the first step you have to take by doing this is divide the both sides by the labor. So when you divide both sides by labor, here you'll be having output. You'll be having output per worker. Then for me to be having output per worker, I'll be able to solve the problem and having the capital per worker raised to power the alpha multiplied by the labor multiplied by its efficiency over L, which is the labor. Then I'll be having 1 minus alpha. So that's the first step. Then this one, automatically, this is going to give me 1 because the labor here is going to cancel the labor as the numerator. Then the output per labor here will now equals to capital per worker raised to power alpha, which is this. And don't forget that this is already 1. Then you're having the efficiency of labor, which is going to equals to 1 minus alpha. So after doing this, you have to move to the next stage. The next stage is that we need to determine your capital per output. And for you to determine your capital per output, I want you to note that. Note that capital per labor, we give you something which is going to equal to capital over Y multiplied by Y over labor, which is your L. So you are going to have this. This is what you're going to have, because if you eventually divide this by this, your result is going to give you this. Your result is going to give you this. And you having this result, I'm just trying to tell you that this capital per labor is going to equal to this. So in short, let me go back to this. So you are going to arrive at this function. So therefore, any place I'm saying capital per worker, I can change it to this. That means I'm going to have my output per worker will now equals to a big bracket of capital per output multiplied by output per worker, then all raised to power the alpha. Then don't forget that you are going to multiply it with the efficiency of labor, which is 1 minus alpha. So just be following me. Then output per labor here, I can rewrite this to be capital per output raised to power alpha, which I'm going to multiply it by output per worker raised to power alpha. Then I'll multiply it by efficiency of labor 1 minus alpha. I hope you are getting it. So if you have any question regarding this, you can drop it in the comment section. So the next thing you are going to do is you divide the both sides by the output per worker raised to power alpha. So here I'm going to have output per worker raised to power alpha divided by output per worker raised to power alpha. So automatically I'm going to eliminate this. That means my next step, sorry, I'll have to use my hand. That means my next step for this, I'm going to have output per worker will equals to let's say output per worker divided by output per worker raised to power alpha. Raised to power alpha here. So I just need to rewrite this. Instead of using this division sign, I'm using the other division sign so that I'll be able to simplify it. Then we now have capital per output. Capital per output raised to power alpha multiplied by the efficiency of labor minus alpha. So the next thing you have to do, now you can see that we have changed this, the capital per worker now here is now capital per output. So what you have to do now is, by applying the law of indices, this is going to give you Y over L, which is the output per worker, now equals to 1 minus alpha. If you apply indices, we are going to get this. So which is going to equals to capital per output raised to power alpha multiplied by the efficiency 1 minus alpha. So you have to have this. So the next thing for you to arrive at your final answer for the Solow Growth Model equation to express your output as the capital per output, you are going to divide the power of the both sides, you divide it by the inverse of 1 minus alpha. Then I'll have capital output per worker raised to power 1 minus alpha multiplied by 1 over 1 minus alpha. You do this to the both sides, then you have capital per output raised to power alpha, then you multiply it by 1 over 1 minus alpha. You do the same thing for the efficiency of labor, 1 minus alpha, you multiply it by 1 over 1 minus alpha. So what you have to do here is automatically this, I've cancelled this. Then I'm left with output per worker equals to capital per output here. Then I'm going to have alpha all over, because alpha times 1 will give you this, 1 minus alpha. then multiply by this 1 minus alpha. I've already cancelled this one for the power of the efficiency too. So then you have your efficiency here. So this is your final equation. So if you're asked to find the outputs with relationship of capital per output, you are going to arrive at this by giving you this function. So this is the end of finding the Solow Growth Model equation. So in case you have any question, you can drop it in the comment section. Please don't forget to like and subscribe to iOS YouTube channel. More is still coming.